Today we'll be working on the idea of rotations, which is your in-class 14 notes, if you'd like to find those. There are three main rotations that we will work on when we're dealing with this particular transformation. And those rotations are 90 degrees, 180 degrees, and 270 degrees. And we are always going to remember that we're rotating counterclockwise, the opposite direction that the hands on the clock move. So if we're rotating 90 degrees, that's the same thing as doing a quarter turn. So if you think about a full turn being all the way around the circle, that would be 360 degrees. 90 degrees would be a quarter of that way, and we're going counterclockwise. So what I'm going to do is take my paper, and I'm going to rotate it toward the left, because that's counterclockwise, but 1/4 of a turn. So basically, it's going to look like it's on its side. So the top of the paper is on the left, the bottom of the paper is on the right. And so what this does is it gives me a sneak peek at what the image is going to look like when it's been rotated 90 degrees. So if I'm looking at this and I'm looking at point A being stuck to the origin, this point B, which is like a sneak peek at where B prime is going to land, is going to be 2 boxes to the left of the origin and 1, 2, 3, 4, 5 boxes up. So what that tells me is that B prime is going to have a negative X value, 2 boxes to the left, and then a positive 1, 2, 3, 4, 5 Y value. So if I flip my paper back around, this is now back to being my pre-image. I can graph this B prime point that I just saw when I rotated my paper on the regular coordinate graph where it belongs. So if I'm starting at A, that's 0, 0. I need to move 2 boxes to the left and 5 boxes up. Count carefully. And that point right there should be B prime. A prime is not going to move because we are using the center of rotation as the origin. So if the point is at the origin, when it rotates, it doesn't go anywhere. So this new ray, A prime, B prime, is going to be the image of my pre-image ray, AB. And if you investigate, I suppose we could get out a protractor and actually measure, but this is supposed to be, and it looks like it is, a perfect 90-degree right angle between that pre-image and image. 180 degrees is going to be like a half turn. So even though we'll end up in the same spot, whether we turn halfway around clockwise or counterclockwise, we're going to practice to always go counterclockwise. So if we take our paper to get a sneak peek at what that new image will look like, a quarter turn would send me on my side like before. That's 90 degrees. So when I do another quarter turn, my paper is now a half turn from where it started, and it's completely upside down. So if we take a sneak peek, A prime is still going to be at 0, 0, and this is now showing me where B prime is going to be. So even though this is going to eventually look upside down, I'm just going to make a quick note on my paper. It looks like to get to B prime, I'm going 1, 2, 3, 4, 5 boxes left. So that'll be -5 as my X coordinate, and then 2 boxes down, -2 as my Y coordinate. So that was my sneak peek at what my image should look like. Let's flip it back. So we see our regular pre-image, and then I'm going to graph B prime at -5 for X, so 5 boxes to the left, -2 for Y, 2 boxes down. A prime is going to stay at the origin, and then I can draw in my new image ray, and sure enough, we've got a nice 180-degree straight angle sitting there. So we have correctly rotated 180 degrees. If it's difficult for you to read your ordered pairs upside down, it might help if you label them with an X and a Y, just so that your brain doesn't accidentally read that backwards. But hopefully with some practice, you'll be okay. All right, 270 is our last one. This is going to be a 3/4 turn. again, we're going counterclockwise. So if I go a quarter of the way, the top of the paper's on the left. If I go a half turn, the top of the paper's on the bottom. So when I go one more quarter, which gives me 3/4 total, the top of the paper is now on the right side. And I'm taking a look at what my image should look like. So again, A prime is going to stay at that origin, but my new B prime looks like it's 2 boxes to the right. So +2 for X, and 1, 2, 3, 4, 5 boxes down. So -5 for the Y. We can flip it back to its correct position. This is my pre-image. Now I'm going to graph my A prime to stay in that exact same spot, but my B prime is going to be +2, -5. And when I graph that image ray in, you might say, wait a minute, that looks like 90 degrees. But remember, that would be a clockwise rotation. And so the 270 is actually back this way when we go counterclockwise. So that's a 3/4 turn, not a 1/4 turn. So the direction of clockwise gives me that nice big 270-degree angle. Okay, now that we've seen our 3 rotation amounts in action, just a reminder from the other day, a rotation is going to be a transformation that turns a pre-image. We're going to go counterclockwise, as we've been talking about and practicing, around a point of rotation. And we can technically rotate around any point, but we are going to use a point of rotation that's always the origin for our problems. And then the given number of degrees is either going to be 90, 180, or 270. Those 3 that we practiced up above. And so with the rotations, the best thing to do is to focus on rotating the 3 vertices. So A, B, and C from your pre-image are the vertices. We're going to get each one of those points rotated 180 degrees using the origin as our rotation center. And then when we connect those A prime, B prime, C prime points, they're going to give us our new image triangle. So if we're rotating 180 degrees, that means that we should be going counterclockwise, like always, a half turn. So we're going to rotate our paper 90 degrees, 180 degrees. So it's going to be upside down. And we're going to take a look at where this image is supposed to land and make ourselves a little list of what A prime should be, B prime should be, and C prime should be. So then when we flip our paper back, we're going to be able to graph those all in the appropriate spot. So if I look at A, this is giving me a picture of where A prime is going to land. It's going to be 1, 2, 3, 4, 5, 6 boxes to the right. So that's +6 for X. And then 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes down. So -9 for Y. For B, we're counting from the origin because that's 0, 0. 1 box to the left will be -1 for X. And 1, 2, 3, 4, 5, 6 boxes down will be -6 for Y. For the last one, we need C. That's 1, 2, 3, 4, 5, 6, 7 boxes to the right. So +7 for our X value. And then 1, 2, 3, 4, 5 down, which is -5 for the Y. And because this is going to be upside down in a second, I'm just going to label the X and the Y columns so that when I flip it back, it's going to be a little bit easier for me to see, even though that's written upside down. So my A prime has an X of +6. That means I'm moving to the right 6. And then I'm going to go for a Y value of -9. So down 9. Hopefully I counted that right. For B, the X value is -1, so 1 to the left. and then the y value is -6, so 6 down. 1, 2, 3, 4, 5, 6. B prime. And then for C prime, my x value is +7. 1, 2, 3, 4, 5, 6, 7 to the right, and then y value of -5, so 1, 2, 3, 4, 5 down to place C prime. That image triangle has been rotated 180 degrees. If we wanted to check it, we could take some kind of a straight edge and we could connect our values that are A and A prime, and we could see, hopefully, a nice straight line through the origin, because that's 180 degrees. So see how the origin and A prime all line up on a nice straight line. The same would be true for B, the origin, and B prime, and then C, the origin, and C prime. Okay. Our next rotation is going to be 90, so we're only going to go a quarter turn. So we're going to go ahead and turn it just 1/4 of the way. So the top of the paper, if we go counterclockwise, is going to be on the left side. We're going to need to take a look at what our A prime, B prime, and C prime points should be. I'm just going to make a list of those three. It looks like A prime doesn't make me go left or right at all, so that means the x value is 0, but I'm going 1, 2, 3, 4, 5, 6, 7 boxes down, so a y value of -7. For B prime, we're only moving to the right, so x will be +3, but since we don't go up or down at all, the y value is 0. And then for C, 1, 2, 3, 4 boxes to the right is a +4, but then 1, 2, 3, 4, 5, 6, 7, 8 boxes down would be a -8 for y. Flip it back, so that goes back to the pre-image location, and then I'm graphing these 3 image points to graph my rotated image. So for A, x is 0, stay at the origin, but go down 7. There's A prime. For B, I'm going 3 to the right, but I'm not moving from the x-axis because the y value is 0. So there's B prime. And then for C, I need to move 4 to the right and 8 down. So there's C prime. And then all that's left is to connect those 3 vertices with nice straight segments for the sides. And now this triangle has been rotated 90 degrees counterclockwise, and that's what the image looks like when that happens. Example number 3 is going to have us rotate 270. We're still going counterclockwise. So that means we need 3/4 of the way around. So we rotate 90, quarter turn. We rotate 180, a half turn. And then we rotate one more time. That's our 3/4 turn. The top of the paper should be over here on the right side. And now we're going to make our list of where our A prime, B prime, and C prime points are going to end up. So if I look at C first this time, that stayed at the origin. So that's just going to be 0, 0. A is 1, 2, 3, 4 boxes right. So +4 for x and 1 down. -1 for y, and B looks like it's 1 to the right, positive for x, and then 1, 2, 3, 4, 5, 6, 7, 8 down, so -8 for y. Flip it back to put it back in its original pre-image location, and then let's carefully graph. C prime isn't going to move, so we can just label that same origin point as C prime. A prime is going to be at 4 to the right, 1 down. And then B prime is going to be 1 to the right and 8 down. So our image triangle, A prime, B prime, C prime, is going to be right there in that bottom section of the graph. And so it seems like it's not gone very far if you're thinking clockwise, but remember that triangle has really rotated all the way around 270 degrees counterclockwise to make it to that location. Okay, there are two more examples of rotating 90 degrees and rotating 270 degrees because those are the tricky ones. I would go ahead and pause the video, go ahead and try those on your own, and then I'll meet you back here and we can make sure they landed in the correct locations. Okay, welcome back. This first one, you should have rotated 90 degrees, so quarter turn counterclockwise. That's going to take this triangle and it's going to rotate it over to the side. So you should have your L prime at -8, -1, M prime at -2, -4, and then P prime is at -2, +2. So it takes this horizontal side of the triangle and it turns it vertical, where P is at the top and M is at the bottom after that rotation. For number 5, you're going 270 degrees counterclockwise, so that would be 3/4 of a turn. So by the time that happens, your P prime lands at -7, 0, so just 7 to the left. Your L prime is at -1, +3. And then M prime is at -7, +6. So that triangle has rotated 90 and then 180, and then it keeps going to make that 270 counterclockwise happen. All right, our last example for today is to describe the transformation that's mapped the pre-image to the image. So again, look for those vertices that don't have the primes. That's your pre-image. And so our goal is to decide what's happened to turn this pre-image triangle into this image triangle. And I can eliminate the option of translation because L doesn't stay at the top of the triangle. And if it did just translate, like slide to a new location, L would always be that top point of the triangle. I can also eliminate a reflection because if this just flips over, L would stay on top if it was over a vertical line, or L would move to the bottom if it was over a horizontal line, and it doesn't do that. L ends up on the side. So this is not a reflection, which means hopefully it's a rotation, since that's the third one we've learned about. So if we focus on the fact that this image triangle is down here in this bottom right-hand corner, that's quadrant 4, if you remember the labeling for the quadrants from algebra, we can kind of test out our rotations and see which one works. So if I'm rotating 90 degrees, that would just be a quarter turn. Does that triangle end up in the bottom right-hand corner when I do that? And the answer is no. It's in the top left-hand corner. So 90 degrees is not going to be a match. If I go another quarter turn, this is giving me a peek at what 180 degrees would look like as a rotation. That doesn't look good either because that's now the bottom but still on the left, and I saw it on the bottom right. So if I go one more quarter turn, that would test out 270. It looks like this triangle now is in the correct location. We just need to make sure those points match up. So if I write down M prime, that's just down 4. So 0, -4 would be that ordered pair. L prime is 1, 2, 3, 4, 5, 6 to the right, and then 1, 2, 3, 4, 5, 6, 7 down. And then P prime doesn't go left or right at all, but it goes down 5, 6, 7, 8, 9, 10. So if I flip that back and just do a quick double check, does M prime look like it's at 0, -4? That looks good. Does L prime look like it's at 6, -7? Yep, that looks good. And so if those two look good, I'm guessing this one's going to be okay as well, but you could count that out and make sure that it's at 0, -10 for a little insurance policy. So this would be a rotation of 270 degrees, but we need to say that it's about the origin because we have to be clear about what point we rotated around. Even though all of our rotations are around the origin, that's not true for math in general. So we always want to be sure we include that in our instructions. All right, to finish up today, we're going to summarize. So take a look at all of the rotations we've done. Does a rotation change the size of the preimage? So preimage compared to image, preimage compared to image. No size changes are happening between those two triangles. Does it change the shape? Looks like the same shape to me, still a triangle, still the same kind of triangle, doesn't get squished or pulled or stretched in any way. But it does, like the others we've studied, change the location of that preimage. It's now in a new spot, not at the same place as it started, but somewhere different on that coordinate grid. All right, we'll see you back in class. Thanks for watching.